There are many times when there will be nozzle penetrations into the stack cylindrical shell. A nozzle is a round pipe or cylindrical connection to the stack. This connection could be used to connect piping, or it could be used for access into the inside of the stack. To add a nozzle, go to Details and then select Nozzle. Add a nozzle by clicking the plus at the bottom. The description is used for documentation purposes to explain the purpose of the nozzle. Enter the elevation where the nozzle centerline intersects the stack centerline. There is a sketch in the help that illustrates how this is handled for a tilted nozzle. Most nozzles are made from pipe, and so to select the size, you select the nominal diameter. If the nozzle diameter doesn't follow one of these standard nominal diameters, then you may select Custom and manually specify the diameter. When you select a nominal diameter that is 12 inches or less, then the actual diameter will be different than the nominal diameter. Not to worry, the software will automatically take that into account. Next, we select the schedule, which will define the pipe thickness if we used a standard nominal diameter. If the custom option was selected for the nominal diameter, then you manually indicate the thickness. The tilt indicates the angle that the center line of the nozzle forms with the horizontal axis. If a nozzle is completely horizontal, then the tilt would be 0 degrees. A 45-degree tilt would tilt the nozzle toward the ground at a 45-degree angle. The orientation is the orientation of the center line of the breech when looking at the stack in the plane view. 0 degrees is along the x-axis, and the orientation angles rotate counterclockwise around the stack. The projection is the length along the nozzle that extends past the outer diameter of the cylindrical shell. It is recommended that you refer to the help diagram for tilted nozzles because the projection is measured along the bottom edge of the nozzle neck. A nozzle will require that a hole be cut in the stack shell, and that hole will reduce the strength of the stack shell. Right now, the nozzle entries will only affect the weight of the stack. If we want to take into account the hole we are cutting in the stack shell, then the breech checkbox should be checked. When it's checked, the stack section properties will take the hole into account. When nozzles are reinforced, they are typically done so by adding an annular reinforcement pad. The repad radial width and thickness are entered here. When the breech option is checked, the repad is considered in the section properties for the stack. We also have the option of entering a round breech on the breech input screens, which were explained in another video. The important thing to note is that the nozzle reinforcement is accomplished with a reinforcement pad, and on the breech screen the reinforcement is achieved by using longitudinal and circumferential stiffeners. The decision about whether to enter a round penetration as a nozzle or breech will depend upon what type of reinforcement you will be utilizing. You may specify that there is a flange on the end of the nozzle, which will be considered in the weight calculations. If there is piping attached to the nozzle, then there could be nozzle loads that need to be considered. The nozzle loads are specified by clicking the nozzle load button. A set of nozzle loads can be added by clicking the plus at the bottom. You have a couple of options. You can either manually enter a description and the 3 forces and 3 moments, or you can use the API standard nozzle loads. The API option refers to API 660 or API 537, which have recommended loadings that are based upon nozzle diameter. If you check the API box, then the nozzle loads are automatically populated. You may then choose a multiplier to be applied to those loads. For example, if the multiplier is 2, then all of the standard API loads are doubled. There are 3 options for selecting where the nozzle loads are applied. They can be applied at the end of the nozzle, at the center line of the stack, or at the nozzle to shell junction. The load type determines which load case the loads will be considered when applying to the overall stack. When the loads are entered, they are entered in the XYZ coordinate system. However, we can choose whether the global XYZ coordinate system is used or the nozzle local coordinate system is used. There is a sketch in the help to illustrate this more clearly. Finally, we can elect to perform a WRC 107 analysis on the local nozzle to shell connection. If the box is checked, then an analysis is performed per WRC 107 to calculate these local stresses, and if they are too high, then you can try to add a repad to lower the stress. It is possible to enter multiple sets of loads on a nozzle. When that occurs, then the application must determine for each load type which set of loads is the worst case, and then it will only apply that worst case load in the overall stack analysis. Each of the loads will be checked for the WRC analysis, but only the worst case will be considered in the overall stack analysis. When complete entering all data, then save the form and return to the main menu. Here you will see a visual representation of the nozzles that have been entered.